Hello viewers, welcome to the lecture. Today we are going to see the part 2 of the commercial FEA tools. I am D. Rajesh Kumar, working as assistant professor in the Department of Automobile Engineering, SNS College of Technology, Coimbatore. Welcome you for the lecture. So as we discussed in the previous lecture video, if you see there are different kinds of categories of softwares they are available commercially for the finite element analysis, right? And you can see they are CAD integrated FEA tools. So these are the CAD integrated FEA tools. The first one is as we discussed in the previous lecture. So here the first one is a SolidWorks simulation, Autodesk Fusion 360 and Inventor Nastron. So they are all having a different features, right? So let us see one by one. First is about the SolidWorks simulation. So this is one of the software which is ideal for the mechanical component validation and quick design iteration. Because if we are designing any design or anything or any component, right? And if we do iteration, that should be updated in the analysis part also, because where we do iterations is if any modifications or if the strength is not attained, what we do is we iterate the geometry of the component, or we will do slight modifications in the existing design, and we will again perform for the analysis. So if the software is not integrated, which means the CAD and the FEA analysis is not integrated, what happens is every time we have to iterate the design, and then we have to upload in the software, and then we have to perform the analysis part. Whereas this CAD integrated FEA tools are one of the tools, they provide hassle-free operations, right? So here everything can be done systematically, and yes. So first is about the SolidWorks simulation. So this is one of the software which is used to perform linear and non-linear stress analysis, model dynamics, thermal simulation, and fatigue studies. So this integrated software seamlessly used to design the workflow. So this software is ideal for the mechanical component validation and quick design iterations. The next software what we discuss in this slide is about the Autodesk Fusion 360. So this is also one of the CAD integrated FEA tool, and this software is used to perform stress analysis, thermal analysis, model analysis, right? So these can be used, right? And this software is ideal for startups, right? And startups and small medium enterprises and agile product development teams. So these are some softwares that are used in the basic stage of the industry, so it cannot be used for the large scale operations, right? And the third one is the Inventor Nastron. So this Inventor Nastron is one of the powerful tool within Autodesk, right? So it is used in the aerospace for great linear analysis and mechanical design environments. So this software is ideally used for design focused workflows requiring Nastron accuracy. So in this slide, we are going to discuss about the enterprise simulation platforms. So there are many softwares, out of which we are going to discuss about the Siemens Sim Center 3D, Altair HyperWorks, and FEMAP, right? So first we discuss about the Siemens Sim Center 3D. So this is one of the multidisciplinary simulation environment with native integration to NXCAD and Team Center PLM. So this software enables the closed loop digital twin workflows. So by using this Siemens Sim Center, the user can perform structural analysis, thermal analysis, flow analysis, and acoustic analysis. So this is a model based systems engineering, and then you can see automated validation and correlation. So this is about the Sim Center 3D. So this is powered by Siemens. The next is about the HyperWorks. They are powered by Altair, right? So this is one of the powerful suite that features pre-processing multiple solvers and industry leading optimization capabilities. Example, topology and lattice optimization multi-solver environment, and advanced composite analysis. The last software, that is enterprise simulation platform, is FEMAP. So this FEMAP is one of the advanced pre and post processing supporting solver, which includes NASTAN, NX NASTAN, and SimCenter with strong aerospace heritage. So this can be used for solver neutral architecture, extensive API customization, and large scale or large model handling. So these softwares are best suited for the large enterprises, right? So the company, the volume of the company is high, and the projects they handle uh, multiple projects, or they handle a huge amount of projects, right? So these kind of companies, they can go for these kind of software, either Siemens SimCenter or Altair Hyperwork or FEMAP. So this can be done. And finally, we are going to discuss about the open source and free FEA tools. The first tool is about the Calculix. This Calculix is used as an open source software, right? And there is no license cost, right? Anybody can use this software. And this software, if you see, they are robust implicit and explicit solver with Abacus compatible input format. So the supporting advanced non-linear material models and contact analysis. The next is the Prepo Max. So these softwares are again open source, and you can see in model graphical interface for Calculix, providing intuitive pre-processing, meshing, and post-processing capabilities with a professional feel, right? And the last one is the FreeCAD. So this FreeCAD is the full parametric 3D modeling with integrated FEM workbench utilizing Calculix solver, enabling complete design to analysis workflows. So here the software, the investment cost is zero. And you can see the compatibility comparison matrix. So understanding solver capabilities helps to match tools to the requirement of the projects, and also for the level of complexity. And you can see universal capabilities, right? The first is about open source tools support linear static analysis, model dynamic, and steady state thermal, and basic formulations. The CAD integrated tools, they help to perform analysis such as linear analysis focused on design validation, limited non-linear capabilities. They are limited, right? They cannot be handled for non-linear capability, right? And the next category is advanced solver. So you can see Abacus, ANSYS, NASTAN, they can solve non-linear models and large deformation dynamics and fatigue life prediction and multiphysics coupling. And the open source solution, so Calculix, so they are strong nonlinear solver, commercial tool, but with fewer pre-built workflow and automated features. So if you want advanced feature, definitely I recommend you to go for the subscription software, because these open source softwares are limited to perform operations. We cannot use to a certain extent, right? And the licensing, you can see the Abacus, CAD tools, MS in Astron, right? So the licensing, depending upon the application and the number of user IDs and the duration of the license requirement, the software cost may vary, right? So here the commercial licensing model, you can see perpetual license can be a key feature, right? So it is a one-time purchase with annual maintenance, and you can subscribe annual or monthly according to your payment method or policy, right? So the next is the token based. They are flexible resource sharing across teams, right? And floating license, so the network can be shared, so concurrent usage can also be possible, which means all the engineers can be linked, and they can work on the same project, and through user we can see the progress of the project. So that can be done using the commercial licensing models. And you can see the total cost consideration. First is the training and ramp up time, that adds the investment, because the people or the user who are using these softwares should be trained properly. Next is the technical support and response time, hardware, right? HPC infrastructure requirement, right? Enterprise platform integration cost, they are all costing features, right? So we have to have an eye on these considerations. Thank you.